Ram transmissions don't fail suddenly. They wear down quietly because of small habits and overlooked details that almost nobody talks about. In this video, we're breaking down the subtle behaviors that slowly damage your transmission, even if it still feels fine today. If you own a Ram, this matters, and the first one is the most common one I see from clients who ask me. Let's begin. Number 10. Shifting into drive or reverse before idle stabilizes. Cold starts are the most mechanically sensitive moments for any automatic transmission. When you start your Ram, transmission fluid hasn't fully circulated yet. The pump is building hydraulic pressure, and clutch circuits are stabilizing. On modern 8-speed automatics, engagement pressure is electronically controlled. The transmission control module calculates clutch fill time and line pressure based on fluid temperature and engine RPM. When RPM is elevated during cold start, often 1,200–1,500 revolutions per minute for the first few seconds, hydraulic pressure and torque input are both higher. If you shift into drive or reverse before RPM drops to normal idle, typically around 600–700 revolutions per minute, you're forcing clutch packs to engage under higher torque load than intended. What happens mechanically? The forward or reverse clutch engages while input shaft speed is still elevated. That creates a sharper apply event. Over time, repeated high RPM engagements increase clutch friction material wear and create minor glazing on friction discs. You won't notice it immediately. You might just feel a slightly firmer thud into gear on cold mornings. Many drivers assume that's normal. It's not catastrophic, but repeated thousands of times, it accelerates wear patterns. Compare two habits. Driver A starts the truck and immediately shifts into gear while RPM is still elevated. Driver B waits 10–15 seconds for idle to settle before selecting drive. Over years of ownership, Driver B's clutch engagement remains smoother, especially in cold climates where fluid viscosity is higher and pressure behavior is more sensitive. Transmission fluid thickens in low temperatures. Engagement under cold, elevated RPM load compounds internal stress because hydraulic modulation isn't yet optimal. This isn't about babying the truck for minutes. It's about allowing idle to normalize before gear engagement. Cold start engagement is one of the highest stress events for clutch packs. It only takes seconds of patience to reduce thousands of harsh engagement cycles over the life of the vehicle. Most owners never think about it, but repeated high RPM gear engagement is a quiet, cumulative wear habit that absolutely affects long-term transmission smoothness. Number 9. Repeatedly shifting between drive and reverse. Without a full stop, most transmission damage doesn't come from racing. It comes from parking lots. When you're maneuvering, backing out of a driveway, doing a three-point turn, adjusting in a tight space, many drivers shift from reverse to drive or drive to reverse while the truck is still slightly rolling. It feels harmless because speed is low. Mechanically, it isn't. Inside the transmission, gear changes are controlled by clutch packs that apply and release based on hydraulic pressure. When the truck is still rolling backward and you shift into drive, the forward clutch has to stop the rotating mass of the drivetrain and reverse its direction. That means friction material absorbs kinetic energy. Even at just 2–3 miles per hour, the driveline has momentum. Multiply that by thousands of parking maneuvers over years, and you're adding repeated micro-shock loads to the clutch packs and planetary gear set. The stress isn't explosive, it's cumulative. You may notice it later as slight delay engaging, drive, a more pronounced bump during gear change, minor hesitation before movement. Drivers who always come to a full stop before selecting the opposite gear dramatically reduce that internal shock. Think about the mechanical comparison. Truck A routinely shifts directions while still creeping. Truck B always fully stops before changing direction. After years of use, Truck B's transmission engagement remains noticeably smoother. This is especially important on heavier crew cab models and trucks used for towing. Extra weight increases rotational momentum in the drivetrain. The transmission is designed to change gears under controlled internal conditions. It is not designed to cancel out vehicle motion abruptly every time you park. Coming to a full stop before shifting directions costs you half a second. Not doing it costs clutch material. This is one of the most common and overlooked habits that quietly shortens transmission lifespan, and most people do it every single day without thinking. Number 8. Heavy throttle. While the truck is rolling backward on a hill, on an incline, even slight rollback creates rotational inertia inside the transmission and drive shaft. When the vehicle moves backward in drive, internal clutch assemblies are momentarily unloaded while the output shaft rotates opposite the intended torque direction. If throttle is applied before that motion fully stops, the forward clutch pack must not only transfer engine torque, it must absorb the reverse rotational energy still present in the drivetrain. That absorption happens through friction material. The torque converter multiplies input torque at low RPM. Under even moderate pedal pressure, multiplication can exceed 1.8, depending on stall conditions. That amplified torque is directed into clutch engagement while the driveline is transitioning direction. From a mechanical standpoint, that creates higher clutch surface temperature during engagement, increased glazing risk over repeated cycles, and elevated hydraulic pressure spikes during clutch apply. In heavier Rams, particularly crew cab 4x4 configurations weighing over 5,500 pounds, rollback inertia is greater simply due to mass. Add larger tire setups, and rotational mass increases further, compounding torque demand during transition. Most drivers interpret a slight bump or firm engagement on hills as normal. Over thousands of repetitions, however, clutch material experiences uneven wear patterns. Early signs often appear as slightly inconsistent engagement during incline launches, especially when cold. This isn't catastrophic behavior, it's cumulative stress. Transmission control modules are calibrated assuming engagement occurs under neutralized rotational load. Applying throttle before rotational stabilization introduces additional thermal and friction load that calibration cannot eliminate. Allowing full stabilization before applying torque minimizes peak stress inside the clutch packs. It's a small behavioral correction with measurable mechanical impact over long-term ownership. Repeated momentum reversal under throttle is not what damages transmissions overnight. It's what wears them down quietly over years. Number 7. Battery voltage instability that you never think about. Modern Ram transmissions are electronically controlled hydraulic systems. Every shift, every clutch application, every pressure modulation is controlled by solenoids that rely on consistent voltage. If system voltage fluctuates, solenoid response time changes. That matters more than most people realize. Transmission control modules calculate clutch fill time in milliseconds. A small delay in solenoid activation can alter pressure ramp rates. When pressure ramp rate changes, clutch engagement timing shifts. What causes voltage instability? A weak battery, a marginal alternator, corroded terminals, aftermarket electronics drawing inconsistent load. Even dropping from 14.2 volts charging voltage to unstable 12.5-12.8 volts under load can slightly affect solenoid actuation behavior. It won't throw a transmission code. It will subtly affect shift consistency. Owners sometimes report inconsistent shift smoothness, random firm shift on one drive, smooth on another, delayed engagement in colder weather. They blame the transmission. In many cases, the root issue is electrical supply stability. As batteries age, internal resistance increases. Cold starts amplify voltage sag. During low voltage moments, hydraulic pressure control may not behave exactly as calibrated. The transmission isn't purely mechanical. It's electro-hydraulic. In trucks equipped with large aftermarket audio systems, light bars, winches, or high electrical draw accessories, voltage fluctuation becomes even more common if the charging system isn't upgraded accordingly. Consistent voltage equals consistent solenoid timing. Consistent solenoid timing equals consistent clutch engagement. A failing battery won't destroy a transmission overnight, but unstable electrical control over years contributes to erratic pressure behavior. And erratic pressure means uneven clutch wear patterns. Transmission durability isn't only about fluid and heat, it's also about electrical precision. Number 6. Ignoring transmission software. Updates and TSB revisions. Most owners assume software updates are just for infotainment systems. That's wrong. Over the years, manufacturers release multiple TSBs, technical service bulletins, that revise transmission shift logic, pressure calibration tables, clutch fill timing, and torque management strategy. These updates are not cosmetic. They exist because real-world data exposed shift harshness, premature wear patterns, or inefficient pressure behavior. Here's what matters mechanically. Automatic transmissions rely on clutch apply pressure curves measured in milliseconds. If clutch fill time is too short, engagement is abrupt. If too long, clutch slip increases. Slip generates heat. Heat accelerates friction material breakdown. Manufacturers collect warranty data and real-world telemetry. When they detect repeated clutch wear patterns or converter shudder cases, they often adjust calibration logic through software, increasing or decreasing line pressure in specific temperature bands, revising torque reduction timing during shifts, or modifying converter clutch lockup behavior. Owners who never visit dealerships after purchase often miss these updates. The transmission continues running older shift logic that may have already been revised for durability improvements. This is especially relevant on models produced in early build cycles of a generation. Mid-cycle calibration improvements are common once data accumulates. You won't receive a warning that says "Update needed." The transmission won't fail immediately. It will simply operate under older pressure strategies that may not optimize long-term wear control. Two identical trucks built the same year can have noticeably different shift behavior depending on calibration version. Updated programming can reduce low-speed shudder, refine 2-3 shift firmness, and improve torque converter engagement timing under light throttle. Software defines hydraulic behavior. Hydraulic behavior defines clutch lifespan. Keeping calibration current is not about performance tuning. It's about operating under the most refined durability strategy available. Most owners never consider that their transmission logic may be outdated, but calibration is mechanical protection written in code, and outdated code can quietly accelerate wear. Number 5. Letting the truck idle in gear for long periods. Idling seems harmless. The engine is barely working. Everything feels calm. Inside the transmission, however, things are not resting. When the truck is idling in drive, the torque converter is actively slipping. The impeller is spinning with the engine. The turbine is mostly stationary because the wheels aren't moving. That difference in rotational speed creates constant fluid shear inside the converter. Fluid shear equals heat. At idle, airflow through the transmission cooler is minimal unless you're moving. In hot climates, especially during summer traffic, transmission fluid temperature can slowly climb even though the truck is not moving aggressively. Now add heavy electrical load, AC at full blast, headlights, aftermarket accessories, and engine idle compensates slightly upward, increasing converter shear. Unlike cruising at highway speed, where the torque converter locks up and reduces slip, idling in gear keeps it unlocked and continuously slipping. Repeated long idle sessions in drive lead to elevated fluid temperature over time, increased oxidation of ATF, premature torque converter, clutch glazing, gradual shift, feel degradation. Fleet vehicles and trucks used on job sites often show earlier converter shudder issues for this reason. Hours matter more than miles. An engine can idle for thousands of hours without visible stress. A transmission sitting in gear during those hours accumulates thermal stress internally. Switching to neutral during long waits reduces load on the torque converter and lowers internal heat generation. It's a small behavioral change, but over years of daily traffic lights, drive-through lines, and job site idling, it adds up. Transmission damage isn't always about aggressive driving. Sometimes it's about how long you leave it doing nothing, while internally it's not actually doing nothing at all. Number 4. Not recalibrating after changing tire size. When you install larger tires on a Ram, you don't just change ride height or appearance. You change the relationship between engine RPM and actual road speed. A jump from a factory 32-inch tire to a 34 or 35-inch setup alters effective gearing enough to change how the transmission behaves under load. The transmission control module bases its shift decisions on calculated vehicle speed, input shaft speed, throttle position, and torque demand. If tire diameter increases but the system still thinks the truck is running factory size, shift logic becomes slightly misaligned with real-world load. What does that look like in practice? The truck may hold gears longer under moderate throttle. It may hesitate slightly before locking the torque converter. On mild hills, it may downshift more frequently than it used to. Those aren't dramatic failures. They're subtle increases in clutch cycling. Every additional downshift is another clutch engagement event. Every delay in converter lockup increases slip time. Slip produces heat, and heat gradually reduces fluid efficiency and friction material life. In trucks equipped with 3.21 or 3.55 axle ratios, the effect is more noticeable because taller tires reduce effective mechanical leverage even further. Now compare two identical trucks running 35s. One is recalibrated properly. Shift points adjust. Lockup timing matches the new load characteristics. Gear transitions stabilize. The other continues operating under factory programming. It works, but over years it experiences slightly more hunting and slightly more clutch workload. This isn't instant damage, it's cumulative stress. Changing tire size is common and often harmless when done correctly. Failing to update calibration after that change quietly alters transmission behavior for the rest of the truck's life. When hardware changes, software needs to follow. That's not extreme advice, it's mechanical consistency. Number 3. Driving for years with worn engine or transmission mounts. Engine and transmission mounts are structural components, not comfort accessories. Their job is to control torque reaction and maintain precise driveline alignment. When you apply throttle in a 5.7L ram, the crankshaft rotates clockwise, viewed from front. That creates counter-rotation force through the block and transmission housing. Mounts are designed to limit that movement within a very small range, typically only a few millimeters under load. Over time, rubber compounds degrade due to continuous heat exposure above 180-200 degrees Fahrenheit in the engine bay, oil contamination from minor seepage, repeated torque cycles during acceleration. As mounts soften, drivetrain movement increases. Instead of controlled torque absorption, you get excess rotational travel. Even an additional 5-10 mm of drivetrain movement alters driveshaft angle under load. Why does that matter for the transmission? Because output shaft alignment is designed to operate within tight angular tolerance. Increased angle variation introduces additional load on output shaft bushing, tail housing bearing, universal joints, transmission rear seal. Repeated angular fluctuation also affects how smoothly torque is applied internally during clutch engagement. If the driveline moves excessively during gear changes, clutch packs absorb variable load instead of consistent load. Symptoms often reported in higher mileage rams with worn mounts include firmer 1, 2, upshift underload, clunk when transitioning from deceleration to acceleration, increased vibration at idle in gear, slight shudder during low-speed acceleration. In many cases, the transmission is blamed. When mounts are replaced, engagement smoothness improves without touching internal components. Fleet maintenance records often show increased driveline-related complaints in trucks operating long-term with degraded mounts, especially in vehicles used for towing or hauling. Mount failure doesn't usually present dramatically. It develops gradually. Allowing excessive driveline movement for years increases cumulative stress on transmission output components and internal engagement consistency. Maintaining alignment stability protects more than ride comfort. It protects mechanical load paths the transmission depends on. Number 2. Ignoring minor torque. Converter, shudder. Torque, converter shudder doesn't start violently. It starts subtly. At cruising speeds, usually between 35-55 miles per hour under light throttle, the torque converter clutch, TCC, engages to eliminate slip and improve efficiency. When operating correctly, lockup is smooth and nearly imperceptible. Shudder appears when friction material inside the converter clutch begins to wear unevenly or when fluid friction modifiers degrade. Instead of clean lockup, the clutch oscillates between partial slip and full engagement. The vibration feels like a faint rumble strip sensation. Most drivers ignore it because it's intermittent and mild. Mechanically, what's happening is repeated microslip during what should be stable lockup. Microslip generates heat. Heat degrades ATF faster. Degraded ATF worsens clutch friction behavior. The cycle compounds itself. Converter clutch material is thin by design. It's optimized for smooth engagement, not repeated oscillation. When shudder is allowed to continue for thousands of miles, surface glazing increases and friction characteristics deteriorate permanently. At that stage, fluid changes alone may no longer resolve it. Data from transmission rebuilders often shows that early intervention, fluid replacement with proper friction modifier spec and recalibrated adaptive values, can significantly extend torque converter life if shudder is addressed early. Waiting until shudder becomes obvious usually means the clutch surface has already suffered advanced wear. Converter replacement costs are substantial compared to early fluid service. 2 trucks experience light shudder at similar mileage. One owner addresses it within weeks. The other drives another 20,000 miles ignoring it. The second truck is far more likely to require converter replacement rather than simple fluid correction. Shudder isn't just annoyance, it's early-stage converter clutch distress. Catching it early is one of the few times in transmission life where driver awareness directly prevents major expense. Number 1. Using the wrong fluid friction characteristics. Not all automatic transmission fluids behave the same, even when the bottle says meets spec or multi-vehicle compatible. Modern Ram transmissions rely on very specific friction coefficients for clutch engagement. Inside each clutch pack, friction material is engineered to operate with a fluid that has a precisely defined friction curve. That curve determines how quickly the clutch grabs, how smoothly it locks, and how much slip occurs during engagement. When a fluid has slightly different additive chemistry, even if it technically meets viscosity requirements, clutch apply behavior changes. Engagement may become slightly firmer, slightly slower, or slightly inconsistent under certain temperatures. What happens mechanically? If friction characteristics are too aggressive, clutch application becomes abrupt, increasing mechanical shock. If too soft, clutch slip increases microscopically during engagement. Slip equals heat. Heat accelerates surface wear. The problem is most noticeable in torque converter clutch performance and mid-gear lockup events. Transmission builders frequently see clutch surfaces showing uneven wear in units serviced with generic compatible fluid instead of the precise spec recommended for that transmission model. Fluid isn't just lubrication, it is a functional component of clutch operation. A deviation of even small friction modifier balance affects how clutch material grabs at different temperatures. The control module compensates within limits, but compensation increases pressure adjustments and adaptation workload. Over tens of thousands of miles, that altered engagement pattern contributes to premature glazing or inconsistent shift feel. Using the exact specification fluid ensures friction behavior matches the transmission's internal design parameters. The engineering behind those specs is not marketing. It's based on clutch material formulation. Most owners never notice the difference immediately, but fluid chemistry defines clutch life more than people realize. Transmission durability depends on matching hydraulic control, friction material, and fluid characteristics exactly as engineered, not approximately compatible. So there you have it. Most transmission damage isn't caused by abuse. It's caused by small, repeated habits that feel harmless in the moment. Fix the habits, control the stress, and your Ram's transmission will last a lot longer than most. Drive smart, pay attention to the details, and I'll see you on the road, buddy.